Okay, so sketch the graph of tan x. Y equals tan x for values of x from 0 to 360. Now I've shown you, right, how to draw the sin x graph, okay? And the cos x graph is obviously very similar. They're all waves, aren't they? Yeah? But when it comes to the tan x graph, okay, something sort of strange happens to it. It shoots off to infinity at certain values, okay? And you've got to remember in the exam what values, okay? So you start off just like we did with the sin x graph. In this case now I'm going to do a scale going up in 90. So in this case I think I can go every 3 as 90 because I've got 12 centimeters here. So I'll be able to get 4 lots of 3 in. So you know, if it's not long enough you can go up in 2s, you know. But this is going to be long enough for me. So I can get 3 there, 6 there, 9 there, and 12, right? So that's going to be 90, 180, 270, 360. Sorted. Now you're going to have to remember this in a non-calculated exam. You're going to have to remember that tan 90, right, doesn't exist. Okay? Because if you type in tan 90 on your calculator, it literally will say math error, right? It's an error. So the curve just doesn't exist there. It shoots off to infinity, basically. So at tan 90, you've got to remember to draw what we call an asymptote, right? You don't have to remember that word, right? You won't have to write it down. Okay, you just got to remember it's a dotted or broken line, right? Like that. Then 180, right, is fine, right? There's no asymptote there, but there's going to be an asymptote at 270. Okay? Right? So there's an asymptote every 180 degrees, right? So you just remember there's one at tan 90, and you skip one, and then there's going to be one at 270. You skip that one, and if we had to go to the next one, 450, then you draw an asymptote there, okay? Unlikely you'd have to do that. But sometimes you have to go back in the negatives, don't you? Sometimes that happens. Well, think about it. You've got an asymptote there. You skip this one, okay? This isn't an asymptote. You skip that one. So then there'll be an asymptote at minus 90 as well. And then, right, the other thing, the key thing to remember then, right, which is quite good, where there isn't an asymptote, tan 0 is 0, right? Tan 180 is 0. Tan 360 is 0, okay? So that's kind of good, isn't it? And then you need to remember that, well, I mean, I remember that tan 45 is 1, right? It's something I remember, so it's increasing, and it increases, but what happens with this curve is, right, is that it increases really quick then, right? Really dramatically, and it sort of shoots off. It gets big, 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 and it goes to infinity. So there's no sort of like upper limit of 1, right? It just keeps on going, keeps on going. And what happens is, it gets ever so close to this line, but it never gets there, right? It just sort of like gets so close, but it just never ever gets there. That's what that asymptote is there for, okay? And it won't get there because tan 90, as I said, doesn't exist, right? It's a math error in your calculator. And what we do then is, we repeat that over here, 180. So there's a symmetry, isn't there? Going from 0 to that asymptote. The symmetry there, okay? You might wonder what's going on here. Well, you just continue the curve, right? And to the right of this asymptote then, this curve shoots off to minus infinity, okay? So then, remember, to the right of the asymptote, it shoots off to minus infinity, just like we got here. So we'll just continue that there. And we've got our answer there. And we're done. We've drawn it from 0 to 360.